Okay, so we're going to have a little look in this video at a bit deeper at batteries and the amount of volts that run around a circuit. Um, so what we have got so far is we've used a circuit with a battery and a bulb. Now when you connect it up, the bulb is quite bright, so you've got a brightness to the bulb. Now what you may have noticed is if I'm going to grab two more bulbs and connect those up. Okay, and what you should notice is that the brightness of the bulb has gone down. Okay, so the brightness of the bulb has gone down. If I put in, our clips will work. There we go. I put in another bulb. Okay, you can visibly see it decrease even more. Okay, so each bulb, the amount of light coming out of the light bulb is changing. Now that is because the electricity, there's not enough power running around there to light them all up. Some people think, oh, it's because the electricity is being used. It's not as such being used. There's the same amount of electricity running around there, but obviously you need more power to light these up. So what we can do is we can change the value of the battery that we're using. Now the easiest way to do that is to start going to into the electronic notation. So to do that, if we click on View, I'm going to go to Pictures and untick that, and we get our electronics. So we need a battery, so we've got a battery here, and we're going to have a light bulb, which we can see here. And the same as before, we click the ends and we can connect them up. So this is a lot more technical way of doing it. You can see the light comes on there. It's more technical. This is kind of more the sort of traditional way of doing it, and if you were working in electronics, that is how you would do it. So let's add more up, and you should hopefully be able to see that. There we go. The light there is not as strong. It's not as yellow a glow. What we can do, therefore, is we can click on the battery. When we click on the battery, it changes our section up here. So I'm going to put this up by a number of volts. And as I put it up, you should notice that these items here, these lights, are getting brighter. Okay. However, I'm going to keep going, and there we go. They've all exploded. So what I've done now is I've put too many volts into that circuit. If I click on them, actually I think I need to bring the number of volts down. So you can see the wires have gone. These are all out there. So we're going to delete it. If I click the delete key, I can replace it. What has happened there is that those items have now too much electricity in them. So each item that you get can take a certain amount of electricity. It can take a certain amount of volts. The more volts that run through it, the brighter it is, the more powerful it will be to a certain point. Now each thing can also take a specific number of volts. So if a light can take 10 volts, anything over 10 volts will break it. Anything under 10 volts will mean it won't be as bright. It does tell you, okay, when you hover over it, I think if you take it off and hover over it, well, it just tells you how many volts are running through it. Okay. But the more things you have in here, the more electricity is running around the circuit, is being taken up by powered by other items, the more electricity you need to run everything to its maximum capacity. So if I was to take one of these out, when I join these two, they will both now explode because there's too much electricity for these. So what I'd like you to do now is have a go at changing to this electronic notation, try and popping in a battery in and some items and see how many volts you can actually get to before things start to kind of explode and blow up. And it's the perfect reason why we're doing the simulation first before we try the real thing.